Hey, 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 it's Dr. J, and today we're going to learn about the area between curves. So we'll get right into it. Given two functions, say f of x and g of x, on the interval AB, if f of x is always greater than or equal to f of x when x is between a and b, which basically means that f is the ceiling and g is the floor. Then the area is the integral from a to b of f of x minus g of x dx. It really is that simple. You just take the definite integral from a to b of the ceiling minus the floor with respect to x. It does require that f and g are continuous functions. I forgot to say that. Continuous functions. And it does require that f is always larger than g for every x in between a and b. The graph is pretty straightforward. It basically looks like f G, write that down here, A, B, yeah. So as long as g of x is below f of x, this integral will tell you the area between the curves, of course, also between a and b as well. So not too far of a stretch from what we've already been working on. So let's go ahead and see an example of this. So f of x is negative 0.1 x squared plus 0.8x plus 5.4, and g of x, I'll draw another graph in a second. G of x is 0.2 x squared minus 1.6x plus 5.2. So find the area between them. Now, with these decimals and such, I'm just going to do a very rough sketch. Maybe I'll do it like here. It's just a very rough sketch. It's a parabola. F is a parabola, has a negative coefficient and a y-intercept at 5.4. So there's F. Oh, I forgot to say A and B. Between x equals 2 and x equals 7. Now we're done with the setup. So we're going to start here at 2. And we're going to go all the way to 7. So that's essentially what F looks like. It's a very shallow curved parabola because the leading coefficient is a decimal. And then G looks like this. It's a little bit steeper, so it's more like this. So there's G. Yeah. And it crosses the y-axis at 5.2, so just a little bit lower than that. That's a pretty good calculus sketch there. You just have to have an idea of what the shape of the graph is, based on the type of function. The y-intercept is always a good marker of where it's located, and then whether it is concave up like G, or concave down like F, based on the leading coefficient. So that's good enough for us. So we want to find the area between F and G between x equals 2 and 7. Right, so that's the interval 2 and 7. So this is what we're finding here. That's our question. And since I already gave you the formula, it's pretty straightforward. The area is going to be the integral. Clearly, F is above G the whole time. That's another thing that should be set straight before you get going. From 2 to 7 of f of x minus g of x dx. It's going to get a little messy with all of these decimals, but we can handle it. So f of x is negative 0.1 x squared plus 0.8 x plus 5.4 minus g of x, use parentheses, g of x is 0.2 x squared minus 1.6 x plus 5.2, and again with respect to x. So that's the integral from 2 to 7. I probably should have done this sooner, but I'm going to do it now. I'm going to distribute the negative. And then I'm going to combine the like terms. When you distribute the negative, it changes the signs of all the terms to the right of that. I'm going to combine all the like terms now. So I got negative 0.1 x squared, negative 0.2 x squared. That's negative 0.3 x squared. The more simplification that you do early in the process, the easier the integration and the other steps are going to be. So I got 0.8 and 1.6. So that'll be 2.4 x. And then I've got 5.4 and 5.2. Positive 5.4. This is now a negative 5.2. So that's going to be positive 0.2. And this is all done with respect to x. So all of that is just the algebra. Now you want to get into the calculus. So go ahead and take the antiderivative. That'll be negative 0.3 x cubed over 3. 2.4 x squared over 2. 0.2 x. And this is a definite integral, so we don't worry about the plus c part. And we go straight to the boundaries, or the upper and lower limits. We go from 2 to 7. So it starts off algebra. Then for one moment, you're doing calculus. And then for the rest of the problem, it's arithmetic. You're just plugging in some numbers. So you should get your calculator out. You got 7 to the 3rd power over 3. 2.47 squared over 2. And then 0.2 times 7. Now here's a cool trick, or a great technique. I put the upper limit on the top row. And then the lower limit, I just put it right below it and I change all the signs. Right? Because remember, the FTC, the Fundamental Theorem of Calculus, episode 2, says you plug in the upper limit, which is 7, minus the lower limit, which is 2. But when you minus the lower limit, you're probably catching on by now. It just changes all your pluses to minuses and all your minuses to pluses. Yeah, so that's a nice technique for doing the calculations. If you want to simplify this a little bit, you can, like I do. 0.3 divided by 3 is going to be 0.1. Let me get my calculator out. Yeah, so 0.3 or negative 0.3 divided by 3, I mean, it's clearly negative 0.1. So that makes those nice. 2.4 divided by 2. Now, if this is not possible, you can skip this step. But the more simplifying you do now, the easier it's going to be later. So I divide the coefficients whenever possible. If it wasn't possible, I would skip that step. It just makes the rest of the problem a little bit easier. All right, and so now it's just arithmetic, and you have calculators, so go ahead and work that out. So you've got 7. Now watch how I'm going to do this, right? I'm going to do this in columns here. So I've got 7 cubed. That's 343 times 0.1 negative. So that's negative 34.3, right? Plus 2 to the third, which I already know is 8. For that one, I'm just using my mind to do it. 2 to the third is 8 times 0.1. So that's this first column here. You can certainly do it in any order that you like. I like to keep things lined up like this. Next one, I got 7 squared, which is 49. Obviously, I didn't even need the calculator for that. Times 1.2. So that's going to be 58.8 minus 2 squared, which is 4, times 1.2, 4.8. And then finally, 0.2 times 7, which is 1.4, minus 0.2 times 2, which is 0.4. Now, if you prefer lining these all up horizontally, you can, but I'm doing it this way because that's the way I've written it down already. So I've got negative 34.3 plus 0.8, which is negative 33.5. I've got 58.8 minus 4.8, which is 54. Oh, that's nice. And then I've got 1.4 minus 0.4, which is 1. So altogether, my area is 54 plus 1, which is 55, minus 33.5. Now, I'll leave it to you as I always do, to decide the order in which you want to add or subtract these. But I mean, I still recommend having some kind of a plan. So my plan was based on the amount of space I had here to work with. So I was just trying to get it all done without having to erase any more real estate here for you. So I know you have to watch this. So, all right. So that's the area between the curves, 21.5. I didn't even have to approximate, but just in case, I would say, if necessary, round as indicated. I should probably just say that for all my decimal approximation problems. Sometimes I say 10th. In this case, I didn't need to round. It already came out to exactly the 10th. But there might be some problems where you need to round, just as it's indicated in the problem. Okay. Occasionally I'll say exact. Like I really want the exact answer, but it really depends. All right, well, that's the sort of introductory result. What made this one so easy was that the A and B is already given. So sometimes, in fact, often, A and B are not given. Now, I almost forgot to give them to you in example 1, and then I realized, oh, shoot, it's example 1. I have to tell you what A and B are. Well, what about example 2? Or I don't tell you what the upper and lower bounds are. I just give you some functions. And you have to figure out what A and B are. Now, I'll start off relatively simple. A is a parabola, and G is a horizontal line. G of x is equal to 3. So you have something like this. So G of x is a horizontal line. Not 3, 2, 3, 1, 2, 3. So this is my x-axis. It's my y-axis. 0, 1, 2, 3. So I've got G of x is a horizontal line. And then f of x is an upside down parabola. Sort of looks like this. There's f of x. All right. Now, how do I know that? Well, I mean, this is calculus, and so this is just a parabola. You can easily take the derivative of this and figure out where the maximum value is. I'm not giving a lesson today on graphing, right? I mean, that would slow down. We'd be here for 2 hours. So I'm going to do all of my graphs in the rapid fire mode. For general purposes, you know that it's a parabola, it's x squared. It's negative, so that means it's concave down. The y-intercept is negative 29, which means it's not even visible on the screen, right? It's way off we call out of bounds. All right, so we're just trying to find this area right here. So A and B are not given. Yeah, so I got to find A and B. And they're actually points on the x-axis. I wrote them up here so that you can see what we're looking for, but so we're looking for these 2 dots, but they correspond to x values on the x-axis. Although I still like to draw them up here because that's when you're looking at the graph, that's where you're going to be looking, at those 2 points right there. All right, the graph really doesn't help unless you have a very good graph where you could zoom in on it and find exactly what those points are. Then you might not need me, right? You can just do it visually. Basically, to find A and B, set f of x equal to g of x. Set them equal to each other. So g of x is 3. F of x is x negative x squared plus 12x minus 29. Set them equal to each other and solve for x. This is just a review of basic algebra. So I'm subtracting 3 from both sides. Oh, I better do it right though. Negative 29, negative 3 is negative 32. I'm going to divide everybody by negative 1. Because I don't like leading negatives when I'm solving an equation. If you took my algebra class, you remember me saying that quite a bit. You can solve it with a leading negative in front, but it's just so much easier without it. And so now I've got x squared minus 12x plus 32 equals 0. If necessary, use the quadratic formula. If you can do it an easier, softer way, then please do that. I noticed that 32 is 8 times 4. And I noticed that negative 8 times negative 4 is positive 32. And I also noticed that negative 4 plus negative 8 is negative 12. So that saves me a lot of time. I don't need a calculator. I don't need a computer. I don't need a formula. I can just use common human intuition to solve this. So I get x minus 4 equals 0, or x minus 8 equals 0. So x is equal to 4, comma, x is equal to 8. So there's your A and there's your B. So that means the area is the integral from 4 to 8. They don't always end up in the right order, so be careful. A must be less than B. So, for example, if you got x equals 8 and x equals 4, I would leave it up to you to put them in the right order. The smaller boundary, that's why it's called the lower limit, and then the upper limit is B. A, B. Okay. And then my f of x was negative x squared plus 12x minus 29 minus my g of x was just the number 3. I'm using parentheses as an extra measure of security, but I don't really need them. I'm going to remove them now. Combining the negative 29 and the negative 3. And now I'm ready for calculus. So all of that was just the algebra pre-school preparation. So our area. So the integral of negative x squared is negative 1/3 x cubed. The integral of 12x is 6x squared. Notice I just did that mentally. It's 12x squared divided by 2, but since 12 is divisible by 2, I just went ahead and did it and got 6. Saves me a little time later. And then negative 32x, and then I'll evaluate that between 4 and 8. And now it becomes an arithmetic problem. So the arithmetic, also called plugging in the values or evaluating the function. Just plug in 8. Now, if you want to keep working horizontally, you certainly can. I like to do it vertically and then just change the sign. Right? Subtracting a negative is the same as adding. Subtracting a positive is subtracting. And then subtracting a negative is adding. I don't know if this makes it any easier, but it certainly saves me space. What I like about this method, again, I'm advertising this method, is it puts them in powers order. So I'm doing all my cubes, then I'm doing all my squareds, and then I'm doing all my linear factors last. Now, I can't really simplify this very much, so let me think about this for a minute. So I've got 8 cubed, which is 512, right? 8 cubed is 512. 8 times 8 times 8. So I'm just going to write this as 512 thirds. And the reason is I've done this before where I divided by 3 and then I have that. Then I don't really want to write that down. So I would rather just write 512 divided by 3. And then similarly, I've got 4 cubed divided by 3, which is going to be 64 thirds. Right? If I just wait on this, I can save the decimals for the very end. Yeah, and then I just have a little bit less stress now, and save the stress for later. All right, so I've got 8 squared is 64. 64 times 6, I never memorized that one, 384. And then I've got 4 squared is 16. 16 times 6 is 96. So I got 384 minus 96. It's 288. I did not wait on that one. I just went ahead and did it. I'm only waiting on this one right now. And then finally, negative 32 times 8 is negative 256. And then 32 times 4. I don't know why I have to, do all this arithmetic with you. You all know how to do that. Oh, that's kind of cool. Yeah. 128, 256. Just get the sign right. It's negative 128. So I've been waiting on this, and then I've got these two numbers here, 288 minus 128. So basically, this tells me the area. So I'm done waiting. Negative 512 divided by 3 plus 64 divided by 3. And then now I only have the decimal one time. Let me read carefully what it says. Does it say exact? It says I may round to the nearest tenth. So I'm going to round this to the nearest tenth. So that's negative 149.3. Rounded to the nearest tenth. And then I got plus 288 and minus 128. So I'm just going to do it all on my calculator here. Plus 288 minus 128. And I get 10.7. So I'm rounding to the nearest tenth. So that's my answer. 10.7. It's kind of hard to confirm that. I mean, unless we went back to the old school method of adding up the areas of the rectangles. So it's just best to be right, you know, than to try to check your answer. I don't know an efficient way of checking your answer. Just, you know, follow your, you know, heart, follow your mind, check your decimals. What do they say? Dot your I's and cross your T's, you know, the old saying. And there you go. Well, let's try another one. Not a lot of variety in this until I start doing the word problems, which might be coming soon. For the next one, I actually want you to graph. I mean, now compared to some of the graphs we did earlier in the semester, these graphs will be a walk in the park for you because they're pretty basic algebra graphs. Now, when I ask you to graph a function, I mean, you can certainly do this on scratch paper, like what I did in the last example, but I think I want a little more detail for something like this. So let's go ahead and graph this. So we've got 4 minus x squared. So let's go 4, 3, 2, 1. All right, so your vertex is at 0, 4. Now, again, I'm not teaching algebra today. I hope you still remember your basic algebra. This is an upside down parabola, so it's concave down. It only has the constant and the square term, so there's no horizontal shifting. It means it's right on the y-axis. It straddles the y-axis. And if you plugged in 0 for x, clearly you would get 4 for y. You could use some calculus. This is the absolute max. I know many of you are concerned about the final exam that's going to be coming next week or this week, depending on when you're watching this video. So, I mean, you could review some of your calculus. You could, you know, figure out the derivative and find the absolute max. It's not a bad idea, but I'm not teaching that today. I'm trying to stay focused, right? And so you're going to click here, right? And then you're going to plug in any other point. I'm going to go ahead and plug in the x-intercept of 2, 0. So 1, 2. You don't have to plot the x-intercept. You can plot any other point that you like. All right. So for the computer software, you have to plot 2 points. Start with the vertex and then plot any other point. So, or any point of your choice. So, you might get some numbers that are not quite as nice as mine. So if you have to plot decimals, I would try to avoid decimals. I would try to find nice whole number or integer values if you like. It's kind of cool when you plot this point on the right side, it'll automatically match it with one on the left. You don't have to plot both. All right. Although you could plot this one as well. I wouldn't bother. Once you've got the graph, you're done. All right, so that's it for the f of x. And then now let's do the g of x. So negative 3x. This is a linear function. It passes through 0, 0. So I would click there first. And then again, I would plot any other point. How about -1 and 3? Right? Notice I'm using mental math. If x was -1, then it would be -3 times -1, which would be 3. It would be a -3 times a -1, which would be 3. So that gives you your second point, -1 and 3. All right, there we go. I know my graph is not as good as yours will be, but please bear with me. Yours will be done on the computer and it'll be very nice. Okay, so there you go. And since this lecture is on area, now find the area between them. So find all this area here. Well, you got to find your A and your B. A and B. And as I mentioned last time, technically A and B are values on the x-axis, but visually when you're looking for those points, you're looking, A is on the left where they intersect and B is on the right. So I like to label them where the actual intersection points occur. Once you find the A, clearly the A is going to be on the x-axis. It looks like that one might be -1. And it looks like this one might be, I don't know, 2 or 3 or 2.5 or 3 or I don't know. I don't want to trust this sloppy, graphing board from Amazon.com that I'm employing to help me understand the question, right? What I really want to trust is algebra. So I'm going to set f of x equal to g of x and solve for x. So I've got 4 minus x squared equals -3x. Set them equal to each other. So move the 3x over here. I like to put it in standard order. Standard is called descending. So the largest power is x squared. That goes first. Then the positive 3x. And then the -4. And then I'm setting it equal to 0 and using basic algebra techniques. All right. Now again, we have another one of these negative x squareds. I don't like solving equations with leading negatives. So divide everybody by -1. I always do the right-hand side as well because the law of, division, the division property of equality is called. If you have an equation and you divide by any number, you have to divide both sides of the equation. But if you've been watching me do this, you'll notice that the right-hand side, it just stays equal to 0. But I still like to follow the principle because it's so important that in the event that the right-hand side was not 0, then this step here, dividing it, would be very important. Plus, it would just be mathematically incorrect to ignore the right-hand side. It's a violation of a fundamental principle. And if we start violating the principles, then the whole system would fall apart. All right, so I've got x squared minus 3x plus 4. Let's go with x minus 4 and x plus 1. No, that doesn't work. Huh. Any ideas? Any ideas? It's not factorable. Bummer. Not factorable. Oh. Ha! Don't worry. Dr. Jordan just made a mistake here. Negative x squared positive 4. I was just about to freak out, or I was just about to use the quadratic formula. Whew. I don't really want to use the quadratic formula unless it becomes necessary. I knew there must have been a minor, I wrote it down incorrectly. This is a positive 4. Then when I divide it by -1, it becomes -4. Looking at my graph, I knew that the answers must be easy. So I got x minus 4 and x plus 1. So x is equal to 4. Oh, look, I was guessing 2.5 or 3. My guesses were totally wrong. That's going to be 4. And then the other one, my guess was right on this one. It was -1. X is equal to -1. So my B is 4. My A is -1. And because my graphing board really wasn't large enough to show that, but this point right here is x equals 4. But it's very difficult to see. The -1 was pretty obvious, right? I mean, that one just kind of was screaming at me, hey, I'm -1. All right. So the whole point with this is if you draw a good graph, then your graph should confirm that your A's and B's are reasonable. And you should not have to use the quadratic formula. It's not that there's anything wrong with the quadratic formula, but I mean, that's not the point of this lesson. This lesson is a calculus lesson, not a quadratic formula lesson. Although, I mean, you still have it. We call it the nuclear option. Right? We hope we don't have to drop the bomb, but if we have to, we will. Sounds very coarse and jaded, but All right, so here we go. The area is the integral from -1 to 4 of f of x minus g of x dx. So all of that work was just to get to this step. F of x was 4 minus x squared. G of x was -3x. I should be using abundant parentheses, and then I can remove them when the time is right. If you don't use enough parentheses, you might regret it later. When you get this, these signs will be all messed up. So I've got 4 minus x squared plus 3x dx. You don't really have to put this in standard descending order. It's not necessary. If you prefer it, you can. So there you go. Some people really like, I'm one of those people, but I don't insist upon it, but I prefer to see my polynomials written out in descending order. Oh, by the way, if you do rewrite it, be careful. I almost screwed this up earlier. That 4 is a positive 4, and earlier in this example, I had accidentally written it as -4 because my brain saw that negative sign there. So I'm a person just like you, I make the same kind of mistakes everybody makes. All right. I'm ready for integration. So I got -1/3 x cubed. I must have a thing for upside down parabolas today. That's sort of that's the dome of this lesson here. Plus 3/2 x squared plus 4x evaluated between -1 and 4. That's it. Believe it or not, that one step was your calculus step. What this whole course was directing you towards was being able to do that step. The difference between this step and this step is what separates calculus students from algebra students. And you've come a long way. Save your tears for my final lecture on word problems. I always have to end on a high note. Oh, look, there it is again. So I've got -1/3 4 cubed plus 3/2 4 squared plus 4 times 4. I just can't resist doing it again. Plus 1/3 -1 cubed minus 3/2 -1 squared. You see, when you line them up like this, it makes it very easy to change the signs because you can clearly look at its corresponding term when you've got them lined up like this. Ooh, exact. I usually pause around this point. Pause and read to decide if I'm going to bust out my calculator or not. If it says exact, keep your calculator offline for a minute and just do it the long way. So this is going to be -64/3. Oh, look, -1 cubed is going to be -1, so that's going to be -1/3. I'm going to go ahead and break my tradition. Since I'm not using a calculator, I'm going to write it all out horizontally. So I've got 3/2 and 4 squared. Well, 4 squared is 16. 16 divided by 2 is 8, and 8 times 3 is 24. -1 squared is 1, and then minus 3/2, so minus 3/2. That one stays the same. 4 times 4 is 16, and -4 times -1 is +4. So I've got -65/3. That's those two. -3/2. That's that one. 24, 16. If you're keeping track, that's 40. Plus 4 is 44. Exact area. So exact. I don't want to use my decimal approximations. All right. So the LCD is going to be 6. Now, you're allowed to use a calculator if you're just lazy and don't feel like multiplying. So 44 times 6 is 264. 3/2, well, that already has a denominator of 2. So I just have to do 9. 3 times 3 is 9. That's going to be -9. And then the 65 is going to be multiplied by 2. 65 times 2. Yeah, because it already has a denominator of 3. So that's going to be -130. So altogether, I've got -130, -9, and then +264. 125 divided by 6. And that's it. That's your exact answer. 125 divided by 6. You could try to like simplify this, but 125 is 5 times 5 times 5. So it's not going to be divisible by 6. 6 is 2 times 3, or 6 times 1. And so there are no common factors to make it reducible. So there you go. Okay, so that is the lecture on area between curves. I do have one more lesson for you, which is the final business math application, business calculus application. But I'm already pushing an hour here. I'd rather just save it for a short video on applications that I'll post in a minute. Let's take a quick break. And until then, I'm Dr. Jordan, and I'll see you on the internet.